All right, so we're working on the 4.1 and 4.2 section homework. All right, and I kind of just wanted to lay out an overview of the process. If we need to find critical points of a function, we take the first derivative and set it equal to 0, because at the critical points, the slope is 0, and that's what the first derivative is telling us. So you can do a first derivative test to tell if it's a local max or min by looking at the sign changes around that point. If it changes from a positive slope to a negative slope, it's got to be a local max. If it changes from a negative slope, right, to a positive slope, it's a local minimum. Now, you can also use the concavity at the critical points to check. And there you would use the second derivative. If the second derivative is positive, that means this is concave up, and at that point, it's a minimum. If the second derivative is negative, that means the graph's concave down, and that critical point is a local maximum. All right? So let's look at this first one. It says, find the x value where this function attains a local maximum or a local minimum, right? Oops, sorry, let's go back. So the first thing we need to do is take the first derivative. So I rewrote this as x over e to the 9x. And I'm going to use the quotient rule. So the first derivative will be the derivative of the top, which is 1, times the bottom, minus the top times the derivative of the bottom. The derivative of the bottom is e to the 9x times the derivative of that exponent, which is 9. So I'm going to bring a 9 out here, e to the 9x, all over the bottom squared. I'm going to do this. I'm not going to simplify that yet. Notice, in the numerator, I can factor out an e to the 9x, and I'm left with 1 minus 9x. And then if I take e to the 9x times e to the 9x, I can cancel that out. So my first derivative is this. Okay? Now, if I set this equal to 0 to find the critical points, what you want to notice is that this exponential, e to the 9x, it will never be 0. Okay, so the only thing you need to worry about is that numerator. So if I take the numerator, 1 minus 9x equals 0, and I solve, I get x equals 1 over 9. Okay. Now, this is where I have a critical point. Do I know if it's a maximum or minimum? Not yet. I'm going to use a second derivative to tell us that. So, let me rewrite the first derivative, 1 minus 9x over e to the 9x, and now I'll take the second derivative. All right? So it's the derivative of the top, which is negative 9, times the bottom, minus the top times the derivative of the bottom, which we said was 9 e to the 9x, wasn't it? All over e to the 9x squared. So let's do some simplifying. I'm going to multiply these through. Coming right up here. Negative 9 e to the 9x, minus 9 e to the 9x, plus 81 x e to the 9x. All right, this is just my numerator for a second. Let me just simplify this, and it's negative 18 e to the 9x plus 81 this is where the x is, e to the 9x. And I'm going to factor out an e to the 9x. And it'll be negative 18 plus 81x. Notice e to the 9x times e to the 9x. So this is my second derivative, okay? The thing to keep in mind again is that e to the 9x is always positive. This exponential function, it's a growth. It's going to go like this. It's always positive. So the only thing we have to look at in terms of sign is the numerator. So I'm going to do this for a second. If I look at this numerator, negative 18 plus 81 times x, and I plug in the point of 1/9, negative 18 plus 81 times 1/9, 81 over 9 is 9. Negative 18 plus 9 is a negative number. That means this thing is concave down, right? Which means our x equals 1/9 is a maximum. So it's got a local maximum at x equals 1/9, and it does not have a local minimum, so it's an NA. Okay? All right. So next, the next problem. We're going to follow along the same way. Find the critical points of the function and classify them as local, max, or min. So I'm going to take the first derivative. So the derivative of x is 1. Let me rewrite this as 16x to the minus 1. So then it'll be minus 16, x to the minus 2, which looks like this. 1 minus 16 over x squared, right? And if I need that second derivative, I'm going to do it right away. The derivative of this is 0. I bring down the negative 2. It's going to be positive 32x to the negative 3, which is 32 over x to the third. All right, to find the critical points, I will take the first derivative and set it equal to 0. So then I'm going to add that to the other side, and I get 1 equals 16 over x squared. Let's just write this as 1 over 1 and cross multiply. X squared equals 16. Take the square root of both sides. X is going to be a positive and a negative 4. So these are my critical points, but I do want to figure out if they're maxima or minima. Maximum or minimum. So when x equals positive 4, I will plug that into my second derivative, and I don't even really care what the number is. I just need to know it's positive. So at positive 4, this thing is concave up, so positive 4 is a minimum, right? At x equals negative 4, if I plug this in, notice if I take negative 4 to the third, that's still negative, so this will be negative. That means concave down, so the critical point there is a maximum. So that should be our answer. All right, this one says find the inflection points and write them in ascending order. Now inflection points come from the second derivative, and you set it equal to 0. So let's find our first derivative and then our second derivative. So I have 4x to the third, right, minus 42x squared plus 120x. Then I'll take the second derivative. That equals 12x squared minus 84x plus 120. All right? Well, we're going to set that equal to 0. Well, what's nice is that we can factor a 12 out of all of these. So if I pull a 12 out, I get x squared minus 7x plus 10 equals 0. So I'm solving. I can divide by this 12 and it goes away. X squared minus 7x plus 10 equals 0, and we can factor. It works out nicely. X minus 5, x minus 2, so x equals 5 and 2, right? Well, she wants them in ascending order, so we're going to do 2 and 5. That's all we needed to do on this one. So to find inflection points, you take the second derivative, set it equal to 0, and solve. Okay? All right, question 9 says, find all the critical points. I'm sorry. Oops. Find all the critical points, and then use the first derivative test to determine whether it's local, max, or min. All right, well, we need to take the first derivative. So the first derivative of this thing is going to be 12x to the third minus 12x. Okay, let's set that equal to 0. Well, I can factor out a 12 and an x here, can't I? I'm left with x squared minus 1. Okay? And then I can even factor this difference of perfect squares. So 12x equals 0, x equals 0. X minus 1 equals 0, x equals 1. X plus 1 equals 0, x equals negative 1. So I have critical points, and if we want to write them in increasing order, it would be negative 1, 0, and 1, right? But he wants us to use the first derivative test, so I kind of like to say if 0, negative 1, negative 1, and 1. Let's see what's going on. All right, so the first derivative is this, 12x to the third minus 12x. All right, if we put a negative number in for x, this is still negative and larger, so this should be negative down here, shouldn't it? It's negative when you have a negative number in there. If I put something like a fraction in, even if I said something, between 0 and 1, I'd have, let's say 12 times 1/2 cubed minus 12 times 1/2. Well, 1/2 cubed is smaller, isn't it? It's 1/8. So this would be 12 times 1/8 minus 12 times 1/2. Notice that that's still negative. Negative, negative, negative. Now, once I get larger than 1, this will be positive. So we have when this goes from a negative slope to a positive slope, that's a minimum, isn't it? So we do have a local minimum at 1, but this, even though 0 is a critical point, the 0 critical point is not an extrema, okay? But one thing we need to do now is look what's happening when this number, when we have something like negative 2 in there. Let's see what we get. 12 times negative 2 to the third minus 12 times negative 2. I believe all right, I was revisiting something here, and I want to just do a little more math to check whether this is positive and negative here. What I am going to find is this right here at 1 changes from a positive slope, a negative slope to a positive slope, right? That means this is a minimum. At 0, I want to check. So if I put 12 1/2 to the third minus 12 times 1/2, right? This is 12 times 1/8 minus 12 times 1/2, which is 12 over 8 minus 12 over 2. So this is 6, and that's smaller, so that's definitely negative. Okay? Let's now try it with a negative in here and a negative in here, because this would be negative 12 over 8 plus 6. Okay, so this, I think, will be positive, but what happens when we plug a negative 2 in? So this will be negative 8. 12 times negative 8 is negative 96 plus 24, so it's still negative. So negative, negative, negative.